before, right? Focusing on the part of how many people uses drugs, then what is the probability that the person selected is a positive. So again, focusing on the condition part first. Which is the row of 50 individuals uses drugs. And out of that, 44 of them has positive results. So the row here is the 50 uses drugs and 44 have positive results. So positive given uses drug, focusing on the row of 50 uses drugs. That's what we had like just a couple minutes ago, right, of the probability. To find the probability of one select is not use drug, given that it is a positive test result. So the condition here is the positive test result, and what we're focusing on is the column of positive test result. So the column of positive test result has two category, right? Uses drug and non-use drug. That's 134 in total. A positive test result, that's 134 in total. And from them, how likely we select a person not use drug is 90. Which is, well, pretty large, right? That, in other words, is called false positive. That is a positive result coming out, but that is not a true positive. It is a false positive. As I mentioned before, the false positive usually is a little larger, and the false negative is usually a little smaller. Why? Because, well, the false negative is more serious case, is much more serious than false positive case. Right, that is false positive test result. If you want to convert into decimal, we can see, right, 90 divided by 134 to give a more straightforward idea. That's 0.6716. And that is called a false positive. It's not use drug, but have given that it is a positive test result. From those who have positive test result, the likelihood you get a person or individual not use drug is the false positive. And of course, another false way is the case that if the person have a negative test result, but actually we found it out is use drug, that's the false negative. So there are 866 and 860, 66, yes, 866 of the negative test result, including 6 are actually uses drugs, and 860 are not using drug. By not using drug and have negative result will be appropriate, but if the one is actually uses drug, that will be a more serious problem. Right, so 6 out of 866 is the likelihood, And if you want to convert to decimal, 0.006. So it is able to control, right? That thing is called the false negative. Right, so when false negative is occur, it is a more serious case. Right? So actually, the individual uses drug, but you're coming out a negative test result, you will not do no action with that individual. Right, like right now the virus, right? If someone tests out to have a negative result, most likely they are not doing anything with it, right? But if actually the individual, the person is carrying the virus, then it will be very, very dangerous. So what they try to do is eliminate this false negative test result to be very, very small. In the meantime, or the false positive test result will be getting larger. Like we can see comparing to the false negative, the false positive is a little bigger. But what we can do is, well, in case the individual tests out to be a positive test result, and for sure nothing, he or she knows that he is not actually using drug in this case or carrying virus or something else, then that person can do another test, and well, the likelihood of doing 2 tests in a row to get both wrong answer or both false answer will be very, very low, right? So that is possibly occurs, right? So the key thing is we want to eliminate the false negative to be very, very low, and in the meantime the false positive will be getting larger. Right, so that is the conditional probability, focusing on one thing and focusing on the condition and to see what is the criteria. These ones related to later chapters of the false positive, false negative case. In other words, called type 1 error and type 2 error. And if you can see, right, the conditional probability is finding the probability of the intersection over the probability of the condition. Right, but sometimes, as we found before, right, the conditional probability, like we select 2 individuals without replacement, well, the conditional probability is a little easier, right? Maybe you did not consider or realize you're using the conditional probability, but actually you did. Right? The first person being selected without replacement, then it is based on the first person's result of either positive or negative to affect the second result. If you can go back, you will see. Like the example of both are negative, which means the second is negative given the first is negative. That's the conditional probability, right, for the second one. Right, and from that example we can see that the first is positive, first is negative, second negative. That means the first is negative. Also, when the first is negative, what's the probability of the second is negative, right, from that example before. So that's called the multiplication rule. When we find the intersection, sometimes the intersection is not that clear to find. Then what we can do is by step, what is the probability of finding A? Then what is the probability of the condition? If A occurs, what is the probability of B occurs? Right. Well, the probability of B given A simply is probability of A and B over the probability of A. We can cancel the denominator, which is the same thing here. But the conditional probability is actually the one taking place here. Like still the example of what we had before of the selecting tool. Well, let's see some examples. If a coin flips twice, which the coin is fair, that the coin has outcome of head or tail. Right, for two coins, the sample space will be both on lands or heads. The first is head, the second is tail, or the first is tail, second is head, or both lands on tails. Right, and of course, if the coin is fair, then each outcome will be equally likely. Alright, for the letter ABC, or letter A that, first flip lands on the head. The B stands for the event that, both flips land on the head. Then the C have the event that, at least one is land on the head. Right. So, first is head. Both of them are head and at least one head. Nice to find the probability. Of B given F. Try to find the probability of B given A, which is both lands on heads, given that the first one lands on head. Which focusing on the condition here. The A here is the first one is head, which the first is head from the sample space. Right, when the first is head, second could be head or tail. Right, what we want the conditional probability is that the probability of both of them are heads if the first one and are heads. Or from the new sample space, we get two outcomes of the new sample space, and only one of that gives the both are heads. So we have the likelihood of 1 over 2. Right, 1 over 2. Then the part B saying, well, probability of B given C. My probability to get both are the heads if there are at least one landing on the head. So we're again focusing on the condition. C is the events that at least one head, which two heads are two of the heads, or at least one, of course. Head and tail, and tail and head. Right, so the event C has 3 outcomes on new sample space containing 3 outcomes, which 1, 2, 3. Right, in that we still have possibly to get both our heads, and that probability is 1 out of 3. So that is this example, right? What we do, we can see while we're focusing on the condition, we list sometimes the new outcome out, right? And if it's not that hard to list, I will just list everything out and see what is the probability of what outcomes of them can follow the probability we're looking for, right? The category we're looking for. So it is important to list the condition first, because for different condition it may be coming out different result. So let's see the next one. Our 2 cards are randomly chosen from a deck of cards. Oh, what's the probability that the first card is an ace? Right. Well, that's 4 aces in a deck of cards, and we do not care what the second one is. We just want to know what happens if the first card is an ace. Well, we do not need to separate the case that first card is ace, second card is what. We do not need that. We only need is what happens if the first card is an ace. So that probability will be that's 4 aces in a deck of cards. That's 52 cards in total, regardless what the second card is, right? Even though without replacement, that is not our concern. Same thing, they could ask, well, what's the probability that second card is an ace? Now, what happened to the first card, if that's ace or not, is actually not our concern. If we want to separate the case that, well, the first card is ace, what's the probability of second card is ace? Or if the first card is not an ace, the second card is an ace. And when we do that, we'll figure out it is same, right? So, which means if they only ask for one card, the second or the other card actually is not our concern. Right, first is ace, but second is not an ace. The first card is an ace, but the second card is not an ace. That but is the same wording as and. Right? So there are two steps event. Probability, the first is ace and the second is not ace. And the thing I forgot to mention is we select two cards without replacement. If with a replacement, that will be easier. Without replacement, that's a little more things, right? First card is an ace, that's 4 cards. We had seen before, right? Step by step. First card is an ace, that's 4 cards out of 52 in total. And we seal 1 on the side, right? That's 4 aces, which 48 are not aces. We select the second one from the pool of not aces part. But instead of 52, we have without replacement, so the card will become 51 instead. So multiply them together will be the probability if you want to change into decimal. Seven, 2, 3, 9, 8 or 0.0724. A second card is an ace given the first card is an ace. It's kind of the second part of the step-by-step event, right? What we have in part B is first is ace, the second part is not an ace given the first part is an ace. Right now it's simply asking for the second part. The second card is an ace given that the first card is an ace. Right, so simply, well, the first card is an ace, that's 4 aces. Right, the 4 aces of spade, aces of club, right, the aces of diamond, and the aces of what? The other one, right? That's 4 cards. Heart, aces of heart. Right, so now is whichever being selected, right? The first one is an ace already. Let's say one being selected out. Now, for the second to be aces, that's only 3 cards possible. And we have 1 card being selected, 1 ace is actually being selected, and still that will be 51 cards in the deck of cards. That's 1/12, 0.0833 if you want to convert into decimal. Right, so that is another example of the what's so-called first one, the multiplication rule here, which the second is affected by the first, and the second part only is so-called the conditional probability. We'll see a couple of things next session, but that is so far for this session.